Hi students, we are going to discuss about searching algorithm. Searching algorithm basically classified into uninformed search and informed search. Uninformed search is otherwise called blind search. Why it is called blind search? We are not providing any additional information about the nodes. That's why this is called uninformed search. Informed search, here we are providing some additional information. That additional information is based on the previous experience and knowledge about the problem. That additionally provided information is called a heuristic. So the informed search is otherwise called a heuristic search. Under uninformed search, these are the classifications: uh, breadth first search, depth first search, uniform cost search. Under informed search, we are going to discuss about best first search, the extended version of best first search, that is A star search, and generated test. Now we are moving to DFS, depth first search. Normally in the traversal order, depth first has three orders: in order, pre-order, post-order. This diagram explains the all three kind of order. In order, we have to start with the left child and the again left node. Then we have to move with the right child. This is called in order traversal. In pre-order traversal, we start with root node, then left child, and again that child left child, then we are moving to the right child. In a post order traversal, we have to start with the left node and right node, then we have to come with the root node. But most frequently used traversal is in order traversal in a binary search tree. Now we are going to see one example in depth first search. See, this is a given problem. Actually, depth first search is implemented using stack concept. That is what is stack? First in, last out. That is in a queue, we have to first in, first out. In a stack, first in, last out concept. See, I drawn one sample stack to explain the concept of depth first search algorithm. See, this is the given problem. In this problem, start node is A and goal node is G. So before going to solve the problem, we should write the adjacency node of the given nodes. For A, what are the adjacency nodes? We can call it as adjacent. The child node as a adjacency nodes. That is, A has child of D and B. That's why we are writing B and D. And B has F and C. That's why we are writing F and C. C has E, G, and then H. So the same way we have to write the adjacency list of all the nodes. Now we try to solve the problem. We start with A. That's why the starting node put into the stack. Once a node is visited, I have to cut that node and add the child of the node in the stack. What are the child of A? That is, what are the adjacent with A? B and D. I added B and D with this stack. Which one is the topmost position? D. That's why after A, we are visiting the D. Here in this graph, I mentioned the number, that above number mentioned the order of node visited. 1, 2, 3, 4, 5, 6, 7. This is the order of node visited. Now the top position is D. Okay. Once it is visited, we cut that and child of D is added here. What are the child of D? Child of D is F. We have to add the child of D here, F. So now after D, the topmost position is F only. So we have to add, once we consider F as a visited, so the child of F is added. What is the child of F? A. So A is added here. But it is a duplicate node. Already we visited the A, that's why it's duplicate. Then next to F, we have to visit next one is B node. What are the child for B? C and F. After visiting B, we have to add C and F. Again, F is the topmost node. It is a duplicate one. We have to leave that. Then we have to visit the C node. If node is considered visited, we have to add the childs of C. What are the childs of C? E, G, H. I'm writing E, G, H. In the top, we are having a H as a top node. So we are visiting the top node H. What is the child of H? A. So we are adding the A in a stack. But already A is visited. That is considered as a duplicate node. After the G is in the top node, we are visiting that. Once we reach the goal node, we have to stop the traversal. So this is the order of node visited. And which one is the shortest path? A, B, C, G. This is the shortest path. This is where the depth first search is working. Next, we are moving to the breadth first search. In a breadth first search, we are following the level order. What is level order? So this root node is called in a level 0, level 1, level 2, level 3. So every level we have to travel all the nodes, that is called a level order traversal. Now we will see this example. See here we start with F. So that F is in a BFS concept, we have to explain using Q concept. What is Q? First in, first out. First the node is root node is added in the Q. So this is F. Once the node is considered as a visit, that is comes out of the Q, we have to add the child of F. What is the child of F? K and D. We have to add the child K and D. So then after next, which one is the first one in a Q concept? First come, first serve. Next D is available. Next we are visiting the D. That is Q is come out of the Q. Then the child of D is added here. What is the child of D? B and E. We have to add B and E. Then which one is the first one in a queue? B. Sorry, K. So after visiting K, the child of K is added G and L. We are adding G and L. Okay. After K, we are visiting B. So the child of B is added here. What are the child? A and C. Okay. The same way we have to visit one by one. This is what every level we have to travel all the nodes. Suppose we reached the our goal node is in the level of 2, 0, 1, 2. We have to stop the execution in the level 2 itself. Suppose our without we are reaching the if we can't reach the goal node, we can travel up to the goal node. Here the goal node is J. That's why we travel up to J. This is the concept of BFS. Next algorithm under uninformed search is uniform cost search. Here we have to use the cumulative cost. Okay. So this is a given diagram. So here root node is S, goal node is G. So here they can give the path cost to that. For a root node, their cost is 0. How to mention that cost is a suffix value. So I start with S naught. Once a node is considered as a visited, the child of that node is added here. What are the child of S? A, B, C. So actually path cost B2, A3, C7. Which one is lesser one? B2 is the lesser one. So next I have to visit B2. What are the childs of B? The G is the child of B. So here we have to write the cumulative cost. 20 plus 2, 22. Actually, in a previous methods, we have to stop when we reach the goal node. But here, again, we are trying to reach what are the other possibilities, or even we are reaching the G. What are the other possibilities are available to reach G? So next to lowest one is 3, A3. So next we are visiting A3. What are the childs for A? D, E, G. We are writing D, E, G here. Okay. For D, 3 plus 3, 6, D6. For E, 8 plus 3, 11, E11. For G, it is 18. Okay, already C7 and G22 is available. Compare these value. Which one is lesser one? D6 is the lesser one. So we are visiting next. We are visiting D6. There is no child for D. There is no need to add anything here. Next, which one is the lesser value? C7. We are visiting C7. What are the child for C? G is the child for C. But we are cumulative cost 7 plus 6, 13. So we are including G13. So we compare all the things. Next to the lowest one is E11. So we are visiting E11. At last we are having 3 G value 13, 18, 22. So which one we have to visit? G13 we have to visit. So this is the order of node visited. S, B, A, D, C, E, G. This is the order of node visited. What is the shortest path here? So shortest path here is S, C, G. This is the shortest path. This is the concept of uniform cost search. So here we have to use the cumulative cost. In breadth first search and depth first search, we won't consider the cost. In a depth first search, we have to travel depth wise using the stack concept. In a breadth first search, we have to travel level wise. So we have to use the concept of Q. Next, we are moving to the informed search, that is heuristic search. In the given diagram, in the above node, they are given some value. That value is called heuristic value. So here we only consider the heuristic value. Actually, in the basic diagram I given that in a best first search we have to consider f of n equal to g of n. In A star search we have to consider f of n equal to g of n plus h of n. So the best first search we have to only consider the h of n heuristic value. I already told her what is heuristic value. That is a value given to the given about the node using the previous knowledge about the problem. So we can start here. Root node is S, goal node is G. What are the child for S? A, B, C. We have to see the heuristic value of here. C has the lowest heuristic value. So we have to choose the node C. What is child for C? C has three childs, D, F, E. So D, F, E. Among these three, which has the lowest heuristic value? E. So next we travel E. Then what is child for E? G. It has a heuristic value of 0. So it's a lesser value. Obviously, it is our goal node. We are traveling this one. In this problem, order of node visited is equal to path. Okay. Next, we are going to discuss about A star search. So, A star search is the extended version of binary best first search. Actually, best first search is otherwise called a Dijkstra algorithm. Actually, f of n equal to g of n plus h of n. So, here I already said that g of n is the actual cost from the start node to node n, and h of n is the estimated cost from node n to the target node. This is explained about this explanation explained about A star search algorithm. We compare A star search algorithm with the Dijkstra algorithm because A star search algorithm, the essence of this Dijkstra algorithm. In A star search algorithm, we have to the target node is combined with the only adjacent node. In a Dijkstra algorithm, the target node is combined with the all other nodes. So here only we have to use the path cost alone. Here we have to consider heuristic also. In A star search, we won't expand all the nodes, but in a Dijkstra algorithm, we have to expand all the nodes. So we see one problem. See the given problem in this problem they given the path cost as well as heuristic table. So we'll try to solve the problem. So now we start with the node here. The in this problem I have to write the above node. I have to return the heuristic value and path cost value here. So in the start node heuristic value is 20. The path cost value is initially 0. So 20. What are the childs for start node? 0. For a 0 there are child is 1 and 3. We have to write 1 and 3. The corresponding heuristic value is 10 and 16. Actually, for A star search algorithm, we have to write f of n equal to h of n plus g of n. So here, heuristic value is 10, path cost value is 6. 10 plus 6, 16. Here, heuristic value is 16 and path cost value is 2, 18. So when compared to these two values, this value is very minimal. 16 is a very minimum value. Then we have to find the child of node 3. Node 3 has the child of 0, 2, 4. Even if we visited 0, that also included here. So 0, 2, 4. For everyone, we have to calculate the f of n, g of n plus h of n value here 32, 19, 20. Compare these three value with these value. This one is the very less value. After this one, after visiting this one, these are the three childs. When comparing these 18, 20, 19, 32, 18 is the lowest value. That's why we visited the 16. So once a node is considered as a visited, we have to add the child of 16. 16 as a child of 0 and 2. So again we are calculating the f of n value, and for this one it is 13, this is 24. Compare all the value, this is the lesser value. Then we have to add the childs here. Again we are calculating the f of n value. We compare all other nodes here available. So at last the destination node only has the very lesser value 16. So we are visiting this. Here order of node visited is 0, 3, 1, 2, 5. But path here is 0, 1, 2, 5. This is about the path value. So in this video, we crisply discussed about the basic types of informed search and uninformed search. I hope you people all understand the problem very well. Thank you, students.